Hello Year 10. In this video we're going to be looking at the first part of the section, Circles 2. Now, we know for a full circle with a radius of r that the area is equal to pi r squared. For this semicircle, then the area would be half of pi r squared, because the semicircle is half of the full circle. And in this case here we have a quarter circle, which we know is a quarter circle because we have an angle of 90 degrees. Then the area would be equal to 1/4 of pi r squared. Now then, this fraction of a circle is known as a sector, and it can be any size. The size depends on how big the angle is here. We actually have two sectors in this diagram, a minor sector and a major sector, because we have two angles. But we're interested just in this small one to start with. So this sector here has got a radius of r and an angle at the centre of theta. It just represents any angle, the Greek letter theta representing any angle. So the area of this sector would be a fraction of the full circle. The fraction is represented by theta divided by 360. So if we think about our semicircle above, it was 180 over 360, which is a half, and the quarter circle would be 90 over 360, which is a quarter. So our fraction comes from knowing the angle at the centre. So this is the general formula for the area of a sector. Now, the curved length, the curved edge of our sector here is known as the arc length. It's called an arc. And since this is the fraction of the full circumference of the circle, then we can use exactly the same idea. So arc length will be equal to the fraction, proportion of the full circumference, radius 2 pi r. That's how we find the arc length of a circle. So now let's look at some examples. These are the examples on page 222 in Caboodle. So in example 1 we have to find the arc length and the area of the sector in the diagram. So you can see we've got our angle at the centre is 106 and the radius is 10 centimetres. So the arc length that's the length, the curved length from A to B, is going to be equal to, well, so let's start with our formula. Theta over 360 times by 2 pi r. Then substitute in the things that we know. We know that the angle at the centre is 106 and that the radius is 10, so we've got times by 2 pi times by 10. Let's simplify that and we end up with 106 over 360 times by 20 pi. Let's put that into our calculators. exactly as I've got written there. And let's write down our simplified answer. That's an exact value. We haven't had to make any decision about rounding just yet, which is the best way to do it. And then turn it into a decimal answer, and we have 18.5 centimetres to 3 significant figures. It doesn't give us any indication in the question about rounding, so we use 3 significant figures. Part B then, finding the area of the sector. Same as before, we know we have a formula, let's use it. Area of sector is equal to theta over 360 times by pi r squared. Substituting into it, we have got 106 over 360 times by pi times by 10 squared. So let's do a little bit of simplifying and pop that into our calculators. And get the exact value answer, 265 over 9 times by pi, and then our decimal answer, 92.5 square centimetres, and again that's 3 significant figures. So that's the end of example 1. Example 2, a little bit different. I'm going to do example 2 in a slightly different way to the textbook. The reason is I'm going to use the formula that we have just learnt and substitute everything into that and rearrange it, rather than try and learn a new formula. So a circle has a radius of 28 centimetres and the sector of this circle has an area of 200. We need to calculate the angle of the sector, and that's going to be to the nearest degree, so we're given some rounding here. We don't have a diagram, and it's always a good idea to see a diagram, so draw yourself a circle. Oops, let's just quickly, there we go. Let's put our sector on it. We've got no idea how big this angle is, so we're just going to draw a general picture. We do know that this is 28, and this is the thing that we have to find. We have to find that angle there, and we know that the area of this is 200. So, area of the sector is 200 square centimetres. We know the formula for the area of a sector is theta over 360 times by, in this case, pi times by 28 squared, and that's equal to 200. As before, keeping everything in terms of pi and simplifying, that will be theta over 360 times by 784 pi is equal to 200. So now we need to find theta, which means we need to start undoing the left hand side. So first of all, divide by 784 pi to leave the term with theta in alone by itself. So theta over 360 is 200 over 784 pi. And then to get theta, we just need to times both sides by 360. So theta is 200 over 784 pi multiplied by 360. And again, I've left everything in exact values. So 200 over 784 pi times by 360 is equal to 29.2325 ... and my answer to the nearest degree is going to be 29 degrees. So as you can see, I've just substituted in the formula that we all know for the area of a sector. Now it's your turn. So I would like you to try some of the questions in 11.2s, which is on page 223 in the Caboodle textbook. Do as many as you can in the rest of the hour, and remember that questions 8, 9 and 10 are extension questions. Good luck!